become a scientist has been a little bit the chance of how things go. When you are a master student, you see a nice topic, you become a PhD student, then you have to think about going to industry or university. And at the time that I had to make the decision, go industry or university, I got a job offered here at TU Delft and I stayed in the university. So the nice thing from environmental biotechnology is that on the one hand I like to work with biological systems, to understand how microorganisms function, how they work together, discover new things. It's a nice complex system, it's not an easy system to study. And at the same time, besides it's scientifically interesting, there's a lot of new processes to develop, which is also very interesting to work on new processes, apply different process engineering aspects and integrate that with the scientific research. As a PhD student, I think the hardest thing is to find not experiments to do, not getting data. The hardest thing is always to be able to contribute in scientific discussions. Find something, find a message you want to tell, and that message should be a bit more than I improved this process, I know a bit better this and this. You should somehow interact in a scientific discussion. And that point is always probably the most difficult to do. But if you find it, science becomes effectively also very easy. And for me, the key starting point is having something which is scientifically interesting. A discussion which is going on among academics about how things work or not work, what's there. And then I always combine that with finding somewhere an application where that question is relevant. And then combine that scientific question with that application. And so it's driven from the research question, but to come from an engineering point of view, find then also an application where it's useful. And that can be in wastewater, that can be in my field at least, in wastewater or in mining or in drinking water or in dental research. In principle, that doesn't matter that much. Well, I think the first thing in choosing a research topic is because you like it, because your own decision. If you try to do research and then you complain that you have to publish papers, I don't think that that's the right way of choosing topics. The first thing is you like it, you see there is something other people don't understand, which you understand and which you like to tell other people, and that's the research topic you choose. And if you choose something sensible, then you also can bring something there. And then automatically things like papers and other things, they will follow. So choosing a topic because it's hot and because everybody is busy and you can publish, that's a way of course to generate an income and maybe to find a position. But in the end, if you really like to do the research itself, it just goes more or less automatic. And then you're also much better in your position as a researcher. Try to work together with people who are slightly attached to what you're doing. So if you work together, if you're a microbiologist and you work together with microbiologists, you often don't learn very much anymore. But if you're a microbiologist and you work together with a chemist or someone in physics, and you talk about the research and why you're studying things and what your interest is you want to resolve, you get also introduced to new methods, and if you use new methods you also often find new answers. And you have also new things to tell. If you stay within your own, say, relatively narrow field usually, where I have been trained, for instance, in the nitrogen cycle, in microbiology, and you stay in that, it's not that easy to find something new. But if you collaborate with other people, other labs who might have interesting equipment, that works usually very good for your career and for your enthusiasm. Yeah, for me the approach is you go to scientific conferences, you read scientific literature, you see people don't say something is vague or something is not well understood, and that's a trigger to start thinking why it's not well understood, what is going on there, what's happening. And you try to analyze that and then say, hey, this is a way where we can go, and then automatically you will find always niches where there's people say this is a known, you start to think about it, you find some answers, you design your research plan on it. In my field you also find somewhere where it can be applied, and you combine that, and yeah, it's a bit automatic. ball rolls then automatically. Well, let's of course use internet nowadays, but also, so on one hand, just search there with the right keywords and etc. But you often get very quickly overloaded with a lot of information. So the best way, besides going there and search for all the different papers and see what's going on, talk with some older people, because they usually have a lot of experience. They can quicker say where to go or not. Don't believe when they say not to go there, because it could well be that it's still interesting. Or visit other labs, or be at the early stage at a conference, because it's in the interaction where you get ideas. From reading papers, you get information, but usually not the ideas. It's from discussion with others where you get the real ideas. Well, the subscription-based databases, they just give a much better organization. Google Scholar gives a lot of information. It's not all well checked, but I'm a bit arrogant enough that I can check myself what's good or wrong, and I think every scientist should have that attitude. But the, say, Scopus, Web of Science databases, they have a more structured approach, so it's easier to search in general. And certainly all kind of features as trying to find out who's referencing papers, how groups are working together. That's in these databases easier, so we easily find places in the world where people might do similar work as what you do. And yeah, then you go look around, and then you use Google often to search these groups, their home pages, see what they are doing, and in that way get ideas for your own research. Yeah, so that depends a little bit in which stage of the research you are, because if you're completely fresh, then you just start reading papers. You read about 10-20 papers and you likely will believe everything which is there. But after you have read a few papers, start thinking about which information you want to have for your research and make a list. What do I want to know if I read a paper? Like experimental conditions, like what was the research question? Just make a list and then make a small database where for each paper you read, you answer that questions which you are interested in. Because it makes that you focus better on what information you want to get out of the papers. And also, I had that same experience, but I think almost every PhD student has that experience. When you start your PhD project, you read a lot of papers, and if you read them 1.5 years later again, you suddenly discover in these papers new things you did not read, did not saw when you first time read it. So in that respect, after you did your experiment, take time to read again a few of the older papers. Helps you again a lot to get information you previously did not notice. Well, there's of course a code of conduct which more or less is rather universal without that there's a strong centralized ethical guideline. I think that's one of the interesting things of the scientific field, that there is a kind of sense of what the ethical conditions are, of guidelines are, principles are, without having, say, a United Nations declaration on the ethics of publishing, etc. And effectively they are rather simple. You cite, if you can use any information literature, you can repeat it, but you cite where you get it from. If you submit a paper and you declare it's new, then it is new. You take care that everybody who is involved is on the authorship list, and on the other hand, that everyone who's on the authorship list contributed to the paper, but also agrees that the paper is submitted. Because I think there quite often things still, it's sometimes thought it's nice to have an extra author. But if you're an extra author, you are 100% responsible for what is stated in the paper. And you can never say that you did not do the experiment but was only co-author, for instance. Well, in principle, if you're a young researcher, you should have a mentor. Normally that will be the professor, but if the professor is not adequate doing his job, find someone else in the research field who can act as a mentor. You always find people around. If you go to a seminar or to a place, you can always communicate. It's good to have someone to reflect your opinion. And usually that's just within the group you can find these people, and the task of people like me now, being a professor, is noticing if PhD students have indeed good ideas to stimulate, to just vocalize it and go to a conference and tell your story and see that indeed if you tell your story you get nice results back. Because I notice of course that a lot of young scientists are very uncertain. Somehow people think that PhD is somewhere a life work, but PhD is just 4 years in your life, and then you have another 40 years to really do your life work. So don't take it too serious. But the only thing is go out, and the safest way is first write a publication, because that you can do private behind your desk with private input. If it's not good, you get it back from reviewers, but no one else will notice. If you go to a big conference and you tell a story and then someone makes a nasty question, it's more difficult to handle that than when you just get comments from reviewers. And once you've gone through that process, you try to find somewhere a platform to present. Because certainly if you have something new, do not publish it in a paper and then go on with it. If you think it's really new, you have to go to seminars, conference, to present your ideas, to present your views, to discuss with people. Because again, that's the only place where you get really new information, or where you get new ideas again based on what you're doing. As a scientist, just stay in your lab, your experiments, and that's it. It's difficult in the field because it is an interactive field. You have to communicate either by going to conferences or writing papers. It doesn't matter. So that's an important issue. The other issue which is good is that if something goes wrong, you're not disappointed. You have to believe in what you do. So if something goes wrong, you just have to take that. Well, that happens, and go on, because you know that finally you will achieve. And usually the first time, I just see your equipment right on the right hand side of me, where I know that the PhD student is now ready for half a year trying to get that equipment running in the way we want to have it running. And that takes time, but if you believe that once you have it running, you know that you can solve an answer which everybody is waiting for, then you will go on with it, and you're stubborn, and you will make sure it works. And usually if you're stubborn enough, you will get it done, and you get your results. Well, within water research there are many topics discussed. It's a bit interdisciplinary journal, so we don't have one big topic. If you look to the papers in water research, they are typically interdisciplinary, not pure chemistry, not pure biology, not pure engineering, but this interaction of chemistry, biology, or chemistry engineering, or biology engineering, and all the topics which are currently discussed in the water field. That's partly things like micropollutants, energy generation with all kind of ways, reuse of water, optimization of the systems, new developments, ecotoxicology. Everything is there, a little is discussed, and water research is typical a journal which gives a platform for this interdisciplinary research in the water field.